welcome everyone here in University of Jyväskylä IT faculty. Welcome to our live stream, the ending of the course TJTS M54 Advanced Topics on Systems Development. The course has come to its end. My name is Professor Pekka Abrahamsson. I work here as a professor of software engineering and information systems. And today we have gathered here to see the results of the 27 projects that have been solving real industrial cases. I will briefly outline what will happen today, and then I will introduce we have some opening words, after which I will then let the stars of today, the students, to present the results. Now let's go further and see what we have here as the few key elements of today. So as you can see, here we have the streaming address. The streaming is live. It will go until about 90 minutes or even more. So I think 16:45 Finnish time, 15:45 CET time, we are ending the show. And important note is that people here in this room have been given 100,000 US which is a very unique currency. It is only working here and today. All of the people here present in Jyväskylä University have now the power to decide which one is the best project. So to be working as a real business angel and making the investment, you can decide to invest all the $100,000 to one team, or you can divide it as you see fit to many teams. Be like business angel. The team with the most money will be the winner. We will find that out shortly before the ending of the demonstration session today around 5 o'clock Finnish time. So the target of the project of the course is fairly straightforward. So we have a real industrial case here. The industry is autonomous maritime industry, and to make things slightly more complicated, we are solving their problems. The customers come from that industry segment. We are also been trying to apply ethically aligned design principles when we design the results. In addition to this, besides that we are choosing one of the available technologies to solve the problem or to address the problem, we're also using the Essence kernel and specifically a way to describe the way of working as to facilitate the development. So these are the three elements that are put together. Now we can go to the one of the main results. So all the results that we see and hear today, they are packaged in a book with an ISBN number, and that book is launched today, and we have the e-book coming out in a few days when we have the formatting straight. But the book has been printed. We will be giving out copies today, and this book contains all the concepts that the student teams have been developing, and some introductory words and other things, but importantly it packages everything together. So today's program is so that after me I will introduce the next speakers, and after the speaking party has been doing, we have the autonomous maritime project presentations done in so that the teams have prepared a 90 seconds, around 90 seconds, a minute and a half video about their, let's say, solution, problem domain. Every video is slightly different. And in addition to that, they have a chance to stand up here in front of you locally and globally and have 60 seconds to say a few words about their project and what are they want to delivering. Then we are continuing straight into the session called project demonstration. So each team has not only defined a case or concept. They went further and they have delivered a demonstration that can be shown today with interaction. So we are going then take the live streaming audience and we will walk through every single demo to show also people viewing what is the idea. Each team will then present their stand also. And so the live streaming is continuous, so you please stay online. And finally we have the award session, jury award, teachers award and the audience favorite, after which we will be closing the event. Now it's my honor next to ask the Dean, Professor Pasi Tyrväinen, to say a few words.
Thanks, Pekka. Yes, I'm happy to see you all here today, so many of you. And this might be an experience that is very critical for your future career. In practice, when you are in the industry, in the working life, you often get into situations when you are thrown into cold water, and you need to practice that also here at the university. This time the cold water is the Baltic Sea, and you are not doing the software containers rather than real containers. How to get them moving in the ships that are cruising across the sea. So it's not enough that you know the technology as such or focus on the methods as typically in this course, but you also need to figure out what is needed and what is valuable for the ones who are willing to order for the new software. So I'm happy to see that you have been able to survive this kind of challenge and are ready to the real life out there. You once in a week will be thrown into cold water. I looked at the results that you had quickly, and it seems that you have been able to do that what you were expected, and it's looking good. It's looking really good. So doing something that you have not been able to figure out how to do it in advance and being able to do it, that will make you stronger in the future working life. And the concepts that you have been able to create look very promising. So I hope we are able to pick up some of those and figure out how to make them live also after this project. So thank you very much for your efforts on working on this. So we will be eager to see the results in a while, so I don't take more time out of your presentations. Thank you.
Thank you, Pasi. Also, now we are proud to have the president of the industrial jury, Jukka Merenluoto, and the other member of our distinguished jury is Ville Huovila, coming from JYU Logistics. But please, Jukka, say a few words.
Okay. So, Jukka Merenluoto from Dimex. I'm heading the 1C Autonomous Maritime Ecosystem. And our vision is to develop the world's first autonomous maritime transport system by 2025. And that's a kind of big vision. It's also a quite clear vision. And one of those initiatives that we are engaging on that is the Sipo Valley program, which I presented to you a couple of weeks ago. And I'm truly excited to see the presentations and demonstrations that you have prepared. It's very exciting. As for the background and the kind of industry view on the topic, the purpose here is to develop a safer, more sustainable and more efficient maritime transport system. And as for Finland, the maritime transport is very crucial. 90% of the exports and 80% of the imports are coming through maritime transport. And also when we look at the global scale, it's a very important topic. We're also looking to see that this smart and autonomous maritime is going to bring lots of new kinds of employment and growth to Finnish companies and Finland. It has already been started, and there's lots of exciting possibilities in this industry. So I'm very excited to hear about your presentations and what you have and the problems you have been solving. So with those words, I'd like to give my thank you to you at this point, and I'm excited to hear your presentations. Thank you.
Thank you, Jukka. And I believe it is time to start the first video. So may I please have the first team coming up here. And the video will start shortly afterwards.
Ohjeistus vaan.
Oh, sorry. Thank you, Jonas. So there is some instructions that the team should know. So when the video has stopped, our audience in the world need 2 or 3 seconds silencio. Silence a bit before you start talking, because we are here unmuting and muting, and I don't know what we are doing, but we are doing something here locally that will take a few seconds. So when the video is stopped, you just take a few seconds pause, breather, and then rock the house. Are we good?
C by Mary.io, the foundation for autonomous fairway navigation. Currently, there is no efficient way to transfer data in the open sea. Current transfer methods use multiple APIs to transfer all kinds of data. As there is no platform for autonomous vessel-to-vessel communications, vessels have to rely on close-range radio systems. Without an existing platform, also ports are lacking the relevant information regarding arriving vessels. Our solution, the OpenSea API, a standardized interface helping vessels to communicate in the same language. OpenSea API does not require the vessel to be equipped with state-of-the-art technology, but works essentially on any device with support for geolocation, like a laptop or even your smartphone. OpenSea API does not rely on direct connection to internet, but it implements peer-to-peer linkage. Vessels or other devices that are connected to each other implementing OpenSea API form the OpenSea network, referred to as Ocean. It enables efficient and fast way of transporting data, bringing ports and the open sea closer together for maritime industry to meet challenges of the future. The foundation for smart and autonomous maritime traffic is here.
Alright, thanks. We are Mary.io, and as you could see from our video, our solution will be the foundation for every other solution. So every other solution in the future needs a way to communicate with each other, and there is currently no API that could do that. It's either for weather, it's either for transportation, cargo and stuff like that. Our API would take all of this and do a unified interface that every single solution could talk over, which is like it's a you need to have it in case if you want to do like other solutions.
So you need us. Sorry.
Thank you so much. Next team, please. Team can pass.
In a world where technology is emerging constantly, the pilotage of ships is still manual work, and every vessel needs a pilot boat when approaching the harbor. There is yet no automated solutions to upgrade this. The domain of smart farewell navigation needs a solution where pilotage will be automated with the help of the newest technology. We in Kamme came up with a solution. We proudly present our newest innovation, Tech Pilot, which is fully automated solution for piloted services in harbors. Tech Pilot relies on sensor technology. We utilize sensors in the bottom of the vessel and in the sea, creating a route for the ship to approach the harbor safely and reliably. Our solution combines the sensor data about the ship itself, and for example, weather information, and suggests a safe route for the ship to arrive and dock the harbor. We believe that by automating piloted services, smart farewell navigation will be more efficient, reliable, and safe in the future.
Okay, thank you. Hello everyone, my name is Alex Virtanen. I'm team lead of Team Kamme, and here with me are Kaisa Rantanen, Ella-Mari Mikkola, Markus Ejala, and Matti Selkämaa. And we have come up with a solution to make fairway navigation more reliable and efficient.
Our solution combines technology and software to create autonomous smart fairway navigation. Our goal is to make pilotage safe again. Please come and visit our booth to get more detailed information and treat yourself with some candies. Thank you.
Give me some $2 as well. Thank you so much.
Hello, we are AC Essence and we provide you with the solution Sabar.
So a solution includes software and a robotic arm, and the software uses algorithm to calculate the container's place and ship's balance in real time. And the system saves container's location, and that's how we can always know the specific spot of each container.
What is cool about this that it doesn't matter if there are 10,000 or 1,000 containers on the ship, it will always stay balanced. Imagine a situation when there are supposed to be 10,000 containers loaded to the ship, but half of them are cancelled just before the departure. Our solution balances the ship during the loading process, so the ship is always perfectly balanced.
We have also included artificial intelligence, so the software uses data from previous deliveries to estimate the delivery time of current transportation. Our solution's main benefits are safety and certainty of the transportation and the accurate schedule management. Thank you.
Well done, thank you. The next team, please.
Logistics as an issue with their supply chain. During the voyage, there's a danger that the cargo gets damaged. Currently, doesn't know about damaged cargo until the customer has received it and submitted a complaint. This leads to dissatisfied customers. Rausko Consulting's solution to this is attaching sensors to containers. Among other information, these sensors collect and send data about speed, flow impacts, life, angle of transportation, air pressure, and humidity. Collected data is sent to tracking system. Through the tracking system, employees can inspect the information of each customer's cargo. The system also alerts the users when cargo has been damaged. In Details page, the user sees what is delivered and where the cargo currently is. This solution allows to reimburse damaged goods quicker. Also be more transparent when communicating with customer. As a bonus, you can use all the data gathered to predict what kind of circumstances prevent the cargo damage.
Thank you. I'm Henry and this is Rausko Consulting. And as some obvious remarks, we are talking about the whole system, not just sensors. We are not just collecting sensor data and sending somewhere. And the second point is that we want to make sure that we are collecting correct data and the data is easily integrated. And as a reminder, the value proposition to UPM is the more satisfied customers right now, and in the long run, less damaged cargo, and in that way, more profits and less waste. And we have a beautiful working demo on our stand number 4. Please come and check it. Thank you.
As more autonomous ships start operating in the world's sea routes, we will encounter a new, critical problem. How can manned and unmanned vessels effectively communicate to ensure and improve safety? Our solution is to enable natural language communication between manned and unmanned vessels. Our goal is to solve this problem by utilizing state-of-the-art natural language processing and artificial intelligence technologies to enable fluent verbal communication between autonomic and manned ships. All communication occurs through conventional VHF maritime radio using natural language. Autonomous ships use multiple natural language processing technologies to understand and produce spoken language, analyze intentions and form sentences utilizing convolutional and recurrent neural networks. An advanced cognitive intelligence is responsible for decision-making regarding communication and navigation. Our solution uploads real-time data to a multi-vendor hybrid cloud data lake, constantly retraining AI deep learning models, enabling augmented data discovery. Combining these technologies, we can make marine transport safer and more efficient and solve large problems concerning autonomous vessels.
So our team name is Code Monkeys, and we set out to solve the problem of maritime autonomous transport systems. More specifically, the problem is that how can manned and unmanned crews discuss with each other, unmanned vessels? And while exploring this problem domain, we found out that most ships sailing in the world right now still use a conventional maritime radio. So our solution is an AI-driven maritime communication system that leverages neural networks. And the idea is that the crew of the manned vessel can discuss and communicate with the unmanned vessel and instruct that, and the unmanned vessel knows how to act upon those instructions. Our solution retains backwards compatibility because it leverages the conventional maritime radio system already installed on top of every ship sailing in the world's oceans. Therefore, our client company can already implement our solution today. Thank you.
Hello everyone, my name is Otto. Here is Anni, Anna, Lily and Julia, and we are a green team. And we think that the process of detecting damaged containers is outdated and we want to make it more efficient with our solution. Please welcome to visit our demo tab for more information.
Thank you.
Maritime operations suffer from two problems: inefficiency of operations and cargo damage. These problems lead to several types of costs. Our solution to this problem are smart containers. Smart containers are containers equipped with sensors that track the container conditions and GPS, which tracks the location of the container. Limit values for the container conditions are entered into a system based on the cargo. When limit values are met, the system alerts users, and if the container is equipped with the necessary systems, it will automatically alter the conditions.
Smart containers have several benefits. First, optimal container conditions lead to less content damage. Second, customers will experience faster and more reliable deliveries because the products are safer and their location is known. Third, efficiency will increase as the collected data can be used to create patterns and forecasts which make transportation more predictable. In the future, even more processes can be automated using IoT applications. Augmented reality can be used as a tool to increase efficiency of certain tasks, such as locating a container.
hello everyone. We are a team KDGL, and our solution is smart containers, which we have equipped with sensors and small computer. This gives us our solutions gives applications for damage control and live monitoring of the container, which is helping to decrease the amount of damages the cargo receives during the transportation process. We're also gathering more and more data in order to make patterns and forecasts about the transportation process, which is making the transportation process itself more reliable and more predictable. And then our solutions also offer possibilities for future applications like IoT and AR applications, like we saw at the end of the video. We have our demonstrations, we are working demonstration about our applications, so you're very welcome to visit our booth at number 7. Thank you. Thank you.
Next team, please.
Hello. We are FICE. And presented us a problem to solve, and we developed a solution. The problem? Delivers containers filled with their products 2.5 million tons in a year via sea traffic. During the transportation, the cargo can face challenging weather conditions and get damaged. The damages are not discovered before the destination, which causes significant operating loss, affects the company's reputation, and decreases customer satisfaction. Our solution? Humidity, temperature and location measuring smart sensor system which uses AI technology. So, how does it work in practice? Sensors are installed to the containers, and if the sensor detects that the humidity or the temperature of the container is above the reference values, it sends a notification to an application. With the application you can check information about ships, routes and GPS, products and notifications. By choosing ships from the menu, you can check all the active ships, their IDs, routes and the amount of the containers. More information of each ship can be viewed by choosing an ID. All of the containers are listed and the condition is stated as good, compromised, critical or damaged. By choosing a container ID, you can see more detailed information. You can check the route, product type and the location. You can also see information about the container's condition, humidity's reference value, value when loading and the latest value. The application notifies if the humidity is above the reference value and determines the condition status based on the difference. With our smart sensor system, you can save costs, improve efficiency, reputation and customer satisfaction, and save the environment.
Okay, hello, we are FICE, and this was our solution. It's based on IoT, and it's easy to create because all the technology already exists. It's also easy to add to already existing containers, so there's no need to buy new smart containers and throw away the old ones. And it's also very easy to modify and develop further. So, for example, you can add fans or something you like to the sensors. If you want to hear more, welcome to stand 8. Thank you.
Thank you so much.
Contego, a simple application to manage container traffic at the smart harbors. Contego offers help to reduce the delays of the containers. It also offers help to control the sudden changes at the harbor area. And it is a great tool to support decision making and communication. The main thing of the application is that with the simple visualization and simple color codes, green, yellow, and red, different level employees in the organization are able to understand container traffic. That was our solution. Contego, come to visit our stand 9. Thank you. Thank you.
Team Performance presents Continuity. Continuity is a weatherproof packaging material applied with sensors that have the ability to track the cargo and its condition through the whole logistics system. Here you will be able to see a 3D construction model of our solution with some cargo inside. Here we have drawn a simplified model on how our container moves in the logistical system. This model also shows how the end product packed in our solution is packed inside already existing containers and shipped to the customer. By using already existing logistics systems and modern containers, we safeguard our products from weather conditions and damage that occur when using normal containers. In addition, no extra investments to the logistics systems are needed. Finally, we will be representing the user interface of our product. Through this interface, the user is able to see the different conditions affecting the product. Also, the interface provides the user with some status information in which condition the product is. Through the interface, the user is also able to search for the product either by the order ID or by even status. Thank you for watching and have a nice day.
Yeah, my name is Nico. We're Team Performance, and as you saw from our award-winning video, our solution is a weatherproof container system that uses already existing containers. What our solution does, it protects the cargo from outer damage, either weather or even physical damage. It not only monitors the damage, it prevents it. Also, we have some smart sensors attached, so we can monitor everything going around and where the container itself goes. If you want to see some more nice animations, you can come to our stand number 10. Thank you.
Our group, Helppo ja Kiva, has developed a solution consisting of sensor technology for customer logistics. The case our group has solved for smart harbor within maritime industry. The case is a part of autonomous ecosystem project that aims to solve the challenges of the company. The problem we have solved surrounds the cargo damages, which can become exceedingly costly for a customer. The damages do not limit themselves to monetary losses, but can cause loss of reputation, which is challenging to rectify. The damages can be caused by weather, physical contact with cargo units, and human error. The damages can be visible or invisible, which are hard to prevent without suitable technology. We have chosen to utilize sensor technology that can easily detect the conditions that can lead to damages and inform the decision makers quickly, allowing for preventive operations such as securing the cargo containers from weather. Since the cargo damages do not only cause monetary losses but also impact the customer's reputation negatively, the damages have severe effects for the customer. Our solution can offer preventive measures for the customer to avoid the financial and reputational losses using the sensor system with cargo containers. After investigating in the technology, our customer will be able to offer predictable service to their own partners and customers with added transparency, as sensor data used in decision making can be stored indefinitely. With our solution, our customer can become the forerunner in maritime ecosystem development and optimize their business and logistic operations.
Okay, hello everyone, we are Lea and we use sensors to make sure that the cargo doesn't get damages, or if they get, we detect them and we can tell our customers that why they are wrong. So if you want to know more, come to our stand number 11 and check out our demo.
Hi, we're Team Nameless. I'm Team Lead Laura. Here's Toni and Jesse, and we have two more team members who could make it here today.
So basically our solution works in a way that we will install sensors inside every container, and the outside of the container there's QR tag located, which will be read by automatic camera system in every checkpoint that the container goes through. In that way we can see who is responsible of the containers, and in case of damages or so on happens, we can check who takes the responsibility for that.
Yes, and welcome to our stand number 12, to learn more about the solution. And we also may have a little surprise there for you to see. Thank you.
Surprise, thank you.
We are Topi's dogs. I'm Anssi Lahtinen. It's Roope Voitola, Santeri Lander, and Topi Tikkanen. Our solution was for the autonomous and remote pilotage of the vessels, and the API is built on to utilize for computing network and nodes. The nodes can be, for example, 5G routers that are located in the vessels, harbors, and different problem areas. Our goal was to enable safe and efficient shipping for different vessels. And welcome to our stand. We are the lucky number 13. Thank you.
Lucky number 13, thank you.
Hi, we are Team Ahma, and our solution is more about an ecosystem for smart harbor system, and it implements a lot of different innovations which you all have done, and we are like a base ground for all of you in harbor systems.
Welcome to our stand. We are number 14.
14, thank you so much.
Hello, this is our smart cargo concept, which is developed for logistics. Let's take a look at how our solution works. This is the harbor foreman Mike. He wishes to inspect information about the containers before loading of the ship starts, to make sure that the correct containers are being loaded and the cargo is undamaged. He puts on his AR glasses and turns them on through a mobile app. Foreman Mike sees the information about one of the containers and its status. This container's information includes its weight, place of origin, destination, and its loading order. Mike will also see that the contents have not tilted and the humidity level is just about right. Therefore, the cargo is probably undamaged and good to be loaded on the ship.
Hi, we are team No Code.
Thanks for watching.
solution is called Smart Cargo, and it aims to bring effectiveness to the process of loading the ship. We want the ship loading to be fast, secure, and safe. And we all welcome to see more about our demo in our stand, which is in the back of the room, and especially if you work in maritime industry, so we're happy to touch around ideas regarding our solution. Thank you.
We are here to present solution for the problem has with cargo damages. Every year, globally, there are cargo insurance applications worth of $60 billion. 30% of these are caused by bad containers. Our aim is to cut these costs. With a new cutting-edge, innovative technology, we believe this is a reality in the nearest future. Our solution is an AI-based sensor field system that tracks any damages occurred to containers and the cargo. Eventually, the AI will learn to predict possible damages in advance and even know if it is reasonable to send the cargo in the first place. This is possible through analyzing the circumstances in which damages have previously occurred. Our sensors are add-ons to the container. The system is called Container as a Service since our solution is offered as a service on an existing containers. The sensors measure temperature, humidity, stability, pressure, and impact. AI learns on the measurements and can calculate which types of damages occur on different types of containers. Through this, it can estimate the probability and severity of the damages. When AI calculates that damages are probable, the replacement goods can be ordered straight away before the cargo arrives at the destination. The benefits of our solution arise from the reduced cost of delay of deliveries, through quicker reaction times, lesser overall damages, and smaller insurance costs.
Hi, I'm Jussi Kausi from Team Summit, and in short, our solution is putting sensors in the container and within the cargo, and these sensors could measure things like humidity, temperature, impact, and location. And this data would be sent to machine learning-based AI system, which would, based on this sensor data, assess and estimate possible damages in cargo. The main benefit of the system would be that the system detects immediately when the damage happens, so the customer can immediately start their procedures on how to deal with the damaged cargo.
Thank you so much.
gathering and handling related to shipping containers in harbors. And our solution uses a computer vision based system that can analyze data about container location and condition without relying on separate sensors. If you're interested in our solution, please come visit our stand.
Stand number 17. 17, thank you so much.
We are a consultant company, Team Best. This is our solution, Tracking. It is an application that both and their customers can use. Tracking exploits Estimo stickers that utilizes Bluetooth Low Energy technology. The work is automated, so all the processes are performed easily and efficiently. We can receive information when the client is receiving the product, so that it can be ensured that the order is delivered. Tracking. Track like a king.
Hello everyone, we are Team Best. I'm the team leader, Suvi. This is Jenna, Elena, and Syria. With our solution, order delays and last minute changes can be avoided. Come visit us to the booth number 19. We have candy.
All right, track like a king. Thank you so much.
Welcome to the future of smart fairway navigation. In this video, we will present our concept for autonomous pilotage, which aims to make piloting more efficient and safe. Fairway navigation is a key problem for autonomous ships, as the fairways are often shallow and narrow. In today's way of operating, the ships are forced to wait at sea for piloted services, and the pilots have to climb aboard the ships. This is both inefficient and unsafe. That is why we believe that the next step towards autonomous fairway navigation is autonomous pilotage. We believe it will have a central role in fairway navigation in the future. How does it work? Step 1. The ship sends a request for autonomous pilotage. Step 2. Vessel traffic service receives the request, and AI-enabled system processes real-time data of marine traffic and surrounding conditions. Step 3. Automatic pilotage system sends optimal route information and pilotage guidance back to the ship. As the artificial intelligence system for the optimization is provided by the vessel traffic services, even ships with less technology will benefit from our solution. We truly believe that our AI-enabled autonomous pilotage system offers the maritime industry a more safe, reliable, sustainable, and efficient way of executing pilotage. Autonomous pilotage towards an autonomous maritime industry.
Okay, so hi everybody, we are Team Water, or part of Team Water, one of us can make it today. As you saw in the video, our ultimate solution is autonomous pilotage, but our solution also considers the cases of ships not being able or wanting to invest on new technology, and our solution takes care of that part also. So if you are interested in the whole of our solution, welcome to our stand number 20. Thank you.
Team 20.
Hello, it's customer service from Port of Vuosaari. How may I help you?
Hello, I'm calling from Company Limited. I'd like to get some information on the whereabouts of a container with the ID of 3567.
Yes, I can see that your identification is okay and you wanted to know information about the container number 3567. Let's see. The container is now on sea and its location is Colombo Express IMO number 9295244. And I can see that right now the ship is on coast of United States and heading to Vuosaari. And let's see, the estimated time of arrival to here at Vuosaari port is June 13th and 2018. And estimated departure from here is June 15th. So that's the basic information of your container. Would you like to know anything more?
Thank you, that's all I need for now.
Okay, thank you for calling. Have a nice day.
So, first things first, let me introduce our amazing team. Team Exclusive Development. So here we have Elina, Emmi and Jani, and I'm Reika. So, on the video, we saw what SHAS does. We saw it in action. But what is it that it actually does? How does it work? So, first of all, we set out to solve a massive problem that we have in logistics, which is that companies lose hundreds of millions of euros every year because of poor logistics. So with SHAS, you can track your containers and plan your operations better. So the competitive advantage for harbors is that they can streamline their activities within their logistics. So we've utilized several different technologies here, including machine learning, GPS, and AR. And by leveraging these technologies, we're able to create a smart harbor system. So please, if you have any questions, come and ask us. We're at stand 21, right on the corner here. That's all. Thank you.
Thank you, Sean.
So hi to all of you, and we are Shipwreck Technologies. We are international team. Jan is from Slovakia and Vlad is from Russia. So our main goal and purpose is to offer some good data and beneficial information for all the stakeholders which are involved in the process.
Yeah, and our solution is really cost efficient because we are using the already existing IDs on the containers. So there is no need for individual sensors. So we are using the text recognition camera in each harbor, so we can track the containers. This information can then further be used for example, customers and unloading and loading process planning. So there is a lot of solutions that can be done with this.
And we are there around the corner. Donate us your monies. Thanks.
Shipwreck. Thank you.
team name is Lights-Off, and it's so nice to have so many of you here. My name is Kristiina Kruunholm, and I am the team leader.
My name is Jaakko Tuomisto.
My name is Sarasen Jesse.
And my name is Hanna Kinnunen.
Yes. Our solution focuses to improve the harbor's environmental safety and the efficiency of the port operations. The entity of the smart harbor environment is achieved with drones and AI. And this was our idea and what it could mean for UPM to port operation in the future. If you have any questions, feel free to meet us on our stand number 23.
23. Thank you.
Maritime transportation is the bloodstream of the whole world. 90% of world's cargo travels by sea. However, systems this large won't work without problems. Human errors have caused 1.6 billion losses between 2011 and 2016 for shipping industry. 75 to 90% of container damage is caused by human error. Logistics suffer damage costs of 5 million euros annually, and more importantly, loss of reputation. We offer solution in form of Caribia 1138 autonomous truck lift. It is developed for situations where machine needs to be dynamic and usable in varying environment. Computer vision creates full situational view of a machine. It will never act careless, but do every task with same precision. While unit holds the container, damage sensor scans container for damage. Neural network spots anomalies from sound waves directed into container structure. Automation creates better view of situation. Caribiaca reduces damages, discovers invisible impairments in containers, is dynamic, easy to implement, creates predictability. Caribia Solutions. Think differently.
We are the Caribia team, and this is Aleksi, Jonas, and Teemu, and I'm Minna. And our solution is automated cargo handling in an autonomous cargo. And this kind of solution is efficient, environmental friendly, and it increases the safety, as you could see in this video. And if you want to hear more, you can come to our stand 24 by the door.
Thank you.
SMACO is the smart container solution that is based on the various sensors in shipping containers. The solution comes with mobile and desktop tools to inspect the containers and to analyze the data gathered. SMACO Mobile is the app to make container inspection simple. It can be used with most mobile devices and offers tools to streamline container inspection and condition monitoring process. With the SMACO mobile application, a harbor worker can scan the QR code from the container to start the inspection. After the scanning, the app shows the overall condition of the container. User can also browse the recent scans and modify the previous reports if necessary. The container administration view allows the user to give comments about the inspection if something is not picked up by the sensors, and to find out why alerts are set in the first place. SMACO Solutions also provide a powerful data analysis tool for desktop computers. Companies can get a comprehensive view of the overall condition of their all containers in one place and analyze what might cause the condition to worsen.
So, okay, we are team PMMP, and I'm the team leader Tuomas. Here with me is Merja, Juuso, Tommi, and Mikko. And we want to also approach this project with a grounded solution that is already, that we can already implement with the current technology available. And this is specifically geared towards harbor workers so they can monitor the condition of the containers while they are in the field, and also for the managers who get the more comprehensive view of the entire fleet. And that's about it. Come visit us in the booth 25, and if you are looking for candy, there is none.
SMACO or no candy?
On this video we will demonstrate one part of our solution, SandTrack, by a brief and simple example. Has multiple problem domains that SandTrack can be a solution for. Damage sensors, which measure different variables related to the damage and quality control, are installed into the containers. The container is loaded into the ship and it can be tracked by the customer on demand. Cargo ship runs into the storm during the voyage. Waves cause damages to the crates inside the container, which is noticed by the sensor. The sensor sends a notification which starts a quality control process within, and the container is checked in the port. A damage report is compiled and sent to the customer via Sandtrack. This report enables the customer to react to the situation faster than before. After receiving a notification of the damage report, the customer can inspect the damages and react accordingly and plan ahead efficiently. Sandtrack provides multiple benefits for all stakeholders.
Okay, hello everybody. My name is Veli-Pekka Paila and we are Group MAMMI. There are two things that we'd like to point out. The first thing is that the sensor technology that we use uses 4G and 3G networks, which might be a problem during a voyage. We've tackled this problem by backing up the system we use with a physical hard drive that gathers all the relevant information from the sensors. And when the networks are back online, the physical hard drive will automatically send the data towards UPM. The second thing is that there have been many similar solutions than ours, but our solution is it's not just the sensor, but also a platform that both the customers can use. Basically, this means that, for example, there is a customer portal that the customers can use to track down their shipments and communicate efficiently with UPM. That's it. We welcome you to our stand, which is number 26, to hear more from us and our solution, and who knows, we might have some trouble.
And we also. Good. Thank you so much.
And our solution for quality challenges is Smart 4.
Thank you. Our process is fully automated so that the cargo which is going into container, there are no workman between the container or the truck. It just load the whole cargo inside automatically. And our aim was to reduce costs, increase efficiency, and of course keep the quality intact in cargo. So if you are pleased with our presentation and if you want to know something more, please visit our stand.
Number 27.
Thank you.
Number 27, thank you so much. later. Now everybody here should have $100,000. May I have a copy of one deck? Okay. So here, ladies and gentlemen, we have here is 20,000 for example, and we will start investing them now, and the video trail will. The video will be now, streaming will continue with starting with stand number 1, so make room for the video to arrive shortly. And make your investments, we have about 1 hour to make the investments. Thank you. And now you can continue with
sinne, mä saan vähän kauemmas tuota kameraa.
Kannattaa olla tossa jotenkin näkyvissä. Mutta joo, voitte aloittaa.
Okay, so hi, we are Meri.io. Here's our solution to API. It's an API based on the REST architecture. it uses here it uses a local network to send the data that it has from here. This computer, or you could think about this as a vessel. So this is one of the ships, and here we have two other ships. And then we can take the data that it has collected, we can move it or do it, then we press save, and what should happen, it comes to the other vessel or computer. So our basically our API works like a foundation for every other solution. So when they try to send data, they can just send it to our API, which sends it back to another vessel or another microservice if you want to use microservices.
This also resolves the problem that there is no internet at the open sea. So this works kind of like mesh network. It creates with API and basic antennas and so on. It's a local internet between the vessels, and so on. The OpenSea API makes it possible to transfer data between the vessels. And when the first vessel that has internet connection, the API automatically updates the data to the internet database. Yeah.
So basically when there are vessels that are completely in the blind or in the dark, it doesn't really matter since they can just save it on their own services, and when they come in contact with another vessel in the range, they can send it to the other vessel which might have internet connection, which sends it to the cloud or something like that, which in case in turn will send it to the port.
Our purpose is that this API is going to be in every vessel in the ocean, even the small ships to the big cargo vessels, and by that creating a big network is but this makes also possible to expand the possibilities. Only this data transfer is just the baseline. You can build smart navigation on top of this.
Yeah, and that's about it. Yeah.
Thank you. Thank you.
Ollaanko täällä valmiita? Ottakaa tää, pitäkää sitä ihan mikkinä. Pitäkää tää menee eteenpäin.
Yeah. I hope you guys in the stream can see this. We are Team Kamme, and our product is TechPilot, which is a sensor that is in the bottom of the ocean, and with the ship sensors you can communicate with the vessel, and that's about it. We have a demo. Can you show the demo? So our solution, like I said, is based on sensor technology. And this is our demo how the sensors work. So the sensors of the ship begin searching nearest fairway sensor, which is here. And there's a data link between the sensors, and you can communicate autonomously and navigate autonomously through the fairway. Do you, Markus, want to say something to stream about our solution?
You can also see the voice in here that these have sensors which connects to every sensor on the vessel, and that creates the smart fairway. So the ships can move secure and dock to the harbor, and that's about it. Thank you.
Yeah, thank you.
Joo, tää on mikki.
Se on mikrofoni.
Svenska. Pratar vi svenska? Ja. Vasa. Mitä? Okay. English. In English. Okay, in English. Meet Sabar, our solution.
Yes, we are having a solution that we have got a software and a robotic arm, and with the software we save information about the cargoes that we are loading into the ship. And when the robotic arm picks the container, it measures the weight of the container and balances the ship.
Yeah, the basic idea is that the ship is always perfectly balanced. The algorithm calculates the balance spot, which is visible on the software, and it doesn't matter if there's one container on 10,000 containers, the ship will always be perfectly balanced. For example, if there are last minute cancellation, then the ship isn't just packed on there, for example, only on the right side. Now the ship is loaded fully and perfectly divided. So yeah.
Our solution's main benefits are safety and certainty.
Okay, so here we have the picture of the ship, and it shows the balance spot right here, and it calculates spot for the next container. So we have lots of data from different containers, and ship's balance is always perfect. We have this kind of knowledge about the containers. We have the sender, ID, receiver, contains, and weight. So yeah, our biggest benefits are the security, and that we know that where every container is located on the ship and what it contains, and also the unloading and dispatching times. That's pretty much it. Thank you.
Yes, thank you. Thank you.
Aika lähelle laittaa palonen. Okay. All right. Welcome to our stand here in Tampere.
How close we have to keep this? Okay.
There's our team. Do you want to come present this?
Shall I speak because I have the microphone? So okay, we'll completely show our demonstration of our application, which is our information system. So first we have this. This is the first when you open the application. So it's very basic. You just fill the information then to log in, and then you will immediately get to this view where you can have a overall view for the information that's needed, but not the specifics yet. So if you have a search bar, you can search for a specific cargo order, and then you click it. Then you will have more specific view for specific order, and you will see information that's relevant for this cargo order. So if you are a UPM worker, you can quickly see what's the condition of the order. Here you can see the red light at the status bar, so it's clearly damaged, and you will get that information immediately. And then it's a green circle there, says that the order status is in good condition. There's no damage in the paper, and there's additional information about the
who is the customer, who is the person in charge, who is responsible for this order, and what kind of cargo there is. For example, this time now it's the paper, and the timestamp shows what's the last time it was online when the data came to the system, and it also shows the route where the cargo came from and where it's heading to, and the schedule. That's basically everything we have at this point.
Hello. Pitsataanko vielä? Hello? Pitsataanko me vielä uusiksi? Okay. Okay, so our crew made an autonomous AI system that works with manned vessels on the world's oceans. Basically, the idea is that our AI knows how to communicate with the manned crews on board the world's oceans. This is our prototype. And the manned crews can basically instruct the AI system, and the AI system can produce voice language to respond to those instructions to avoid conflicts. We use old conventional VHF radios that are installed on board every single ship sailing in the world's ocean, so it's backwards compatible. Nobody else needs to build anything on top of the system. That's it.
Thank you.
Kiitos.
Laitetaan teidät nettiin.
Tuossa on mikki. Minuutti pari.
Paljon.
Minuutti pari englanniksi.
So we have here our smart floor solution. It is practically is about a solution to fully utilize the automated system to move cargo into container so that the cargo is not going to damaged. It's not going to get damages during the process. Also, it is fully embedded IaaS system so that you can use it by any mobile devices or computer or whatever device you want to. And also you can see here a demonstration how the smart floor actually works. Basically the work lift come here and drop the cargo, and then the smart floor is activated and it begins to load the cargo where it belongs, and that's all it. Thank you.
Miten siinä näkyy tällä hetkellä?
Ota yleiskuva-aika ja zoomataan vaikka siihen.
Okay. Okay. So we are the team TMMT, and we are presenting you our solution SMACO, the smart container. The solution utilizes sophisticated IoT sensors, which have been weather tested, and to collect data from for the condition of the container. And here we can see the SMACO product family. Okay, so we have decided to go with a very grounded approach that can be easily implemented with or without the sensors to get a kind of centralized register of the containers. So here we have the two possible views to our system. Here's the SMACO mobile, which is meant for the harbor workers. So through our persona, Harry the Harborman. So it uses the QR codes, which have to be which authorizes also the employee. So not just anybody can go and check the container data, because you have to be an authorized employee to see that kind of stuff. And from the container, you can see the different kind of views there. Juuso will give a short presentation here. So as we can see here, after the scanning, it seems that the sensors have not, in this case, given any kind of indication that something is wrong, but through manual inspection, the Harbour man is able to see that there is something wrong with the product. So here we can see that Harry put down his manual notes on the subject. So instead of pen and paper, they now have one centralized system to also input manual findings on the container. And now it has been updated to the register. And here we can see our recent containers. And here is also our desktop view for the managers. And this view here enables the managers to have a full view of the fleet and do some initial analysis from the larger datasets of different containers. And maybe you can show the register one more time. So recents here. And as we can see here, and here we can see that the recent manual update has now updated into the container info. And now we could walk through the sensor installed one. So here we go to the damaged container demo. So now the sensors have given a warning that something is wrong. So one of those many sensors that we have inputted to the container has now given an alert that something is wrong. And as we can see, temperature, light exposure, acoustics, vibration and battery level all seem at a reasonable state, but something is wrong with the humidity. And here we can see the kind of warning message that the system is giving. So it's registering too high levels of humidity. So now Harry the Harbourman can give his own personal comments if they wish, but that is also registered as a kind of update on the condition of the container. And yeah, that's pretty much how it works. And in the kind of, to go back on the manager view, this also provides some kind of little analysis tool for if the managers want to allocate some resources. So there seems to be many alerts from one shipment, so they can allocate the harbor resources to kind of preemptively come and check the shipment if it seems that there's kind of many alerts in the same shipment, and then they can start to find out why that is. So okay, that's that. Thank you.
Aika tulee vastaamaan.
Yeah, thank you.
Yritetään mahdollisimman paljon pitää tätä tasassa. Jos se on päivitystä, niin näytetään niitä, mutta se on
vaikea.
Se on vähän.
Ciao, tultais kuvaamaan.
Yes. Heiluttaminen voi vaan tuoda vähän
liikuttaa silleen, että se tekee tasaisesti, että se tekee. Kuka meistä haluaisi esittää?
Minuutti pari ja mieluusti englanniksi.
Okay, imagine you're in a harbor now, and the system now is outdated because the harbor workers walk around the harbor and try to find damaged containers. So we made this smart camera system where it's a cape and smart cameras which works with machine vision, and they find if there's a damage in the container, and if there's a container you can see that in our application here, and workers don't have to walk around the harbor and look for the damages because they can see it from here. Thank you.
Yeah, so solution is smart containers, which include a small computer and then a few sensors inside the container. The idea is to gather some data to our application, and then the customers can monitor live the situation of the containers, where they are, and so on. And in the future, the idea is to use the data to create patterns create patterns, and in that way and forecast to make transportation more reliable and predictable. But here we have a working demonstration, and Anna will tell you a little bit more about it.
So this is our demonstration. It's a mobile application, and you can log in and see here are the warnings. Since we have told that the inside humidity in the container has exceeded over the limit value, so this gives a warning. But you can mark this as red now and go back, and you see here 3 notifications. For example, the container from Hong Kong is now left to Busan, and mark this as red as well. Go back, and you can also see all the containers on the map. So you can also search with the ID, and then you can see listed all the containers, the container type, the content, and the status if it's okay or warning. And when you click the container, you can see container view from one container. And here you can see the temperature, air pressure, humidity. They are all right now. And here's the location as well. And you can see the activity log. You can see that the container is loaded and it has departed also. And you can track the route of the container. And you can see the settings as well for the maximum limits for the temperature, air pressure, and humidity. Yeah.
Englanniksi. Okei. Voisiko saa aloittaa? Okay, so the problem for us was that the cargo gets damaged in the containers due to weather conditions such as humidity, but the damage is not noticed by UPM until the customer has opened the container and filed a complaint. This costs time and money unnecessarily, and because the product needs to be shipped and replaced. We came up with a solution that is based on Internet of Things, and our solution is sensors which measure humidity, temperature, and location. The data is sent from the ship to the head office, where a person from now in the beginning, but later on an AI, looks at the data and decides what to do next. They can either contact the customer, or then the factory and order a new product, or then the transport company. Great, thank you. Okay, and here is our demo. It's this application we've created. So first, you choose the ship, which one you want to look at. These are there organized by their ID. And there you can see all the containers in there, and you can see what their condition is. It can be good, compromised, critical, or damaged. And then you choose the container which one you want to look at, and then you can see more detailed information about it. You can see what kind of product is in the container, and you can see the reference values of the humidity, what it's supposed to be, and then you can see what it's now and when the measurement was done and where. And you can also see a map where the container is currently going. And based on the value, it's decided whether it's critical or compromised or good. Thank you.
Joo, mä voin puhua. Pihaaks mä?
Minuutti pari ja englanniksi mieluummin.
Okei. Sanokaa vaan kyllä. Joo, ootas mä kaivan sen demon Mulla on paremmin se tässä puhelimessa. Jos se näkyy. Yes. Okay, so this is our solution, Contago, a simple application to use to manage container traffic at the smart harbors. And the main thing of the application is that everyone of the organization can use that, so to see how the containers are moving at the harbors. And in the early stages, the container color codes are based on the checkpoints. So for example, if the container is early on the checkpoint, still goes green. And if it is on late, it goes red. And if there's something issues which are still fixable, it goes yellow. And the later the artificial intelligence can decide and give suggestions for the containers and for the management, for example about rescheduling that those containers are not making through or something like that. And this is the application demo. So basically this is the main map view, and you can see the containers here, green containers, yellow containers and the red, which are errors. And you can see the statuses of the containers here and send requests, and the later sections also reschedule. And from the status section you can also see every containers, and for example these are the green ones, so everything is okay. So the simple application that can be used in every one of the organization. Thank you.
Thank you.
TV-esityksen aika. Jaha. Mä oon ainut, joka tällä hetkellä paikalla. Tää oli meidän toinen.
Se on helppo valita. Minuutti 2 ja mieluusti englanniksi.
Mieluusti englanniksi, kyllä. Okay. So we have basically a container within a container. We're building our own containers, which will provide an additional physical layer of security for the goods. Also because we can't be entirely sure that the owners of the marine containers are willing to allow sensors on them. So if we have our own containers, we can definitely put the sensors on them to track temperature and humidity and so on. So we have a rough sketch of our user interface over here, where we can select a container and see what it contains, in this instance paper, the temperature, humidity, the last location, and whether the container is open or not. And katkosyhteys, okei. Okay. Okay, so we're back. We're back live. So we can assign different values, for example humidity, And if the sensor indicates that humidity has gone over the desired value, the user interface immediately informs the users like, okay, we have a problem here. And because of this, we can instantly inform the customers that we are possibly having some serious issues with the goods we are sending you. And if the delivery time is like 3 months by ship, for example, to Australia or somewhere, and we get information on damaged goods after the first 2 weeks, we can immediately send replacement goods to the customer and increase customer satisfaction this way. I'm not entirely sure what else I'd mention right now, so thank you.
Thank you. Live-lähetyksen aika.
Minuutti pari ja minuutti.
Okei. Voiko tätä antaa noille muillekin sitten puhuttavaksi?
Sanot, eikö se ole helpompi vaan?
Okei, joo.
Mutta voin mäkin.
Joo, hyvä. Selvä.
Pitää kuulla mitä sä sanot, että mä noisin.
Joo, tosiaan meidän ratkaisu englanniksi vai suomeksi? Okay, so our solution will answer for the problems the UPM logistics company has regarding the damages that are visible or invisible with the cargo and logistics. So of course the problems cause monetary damages and also reputational losses, which are very hard to rectify even in the long run and may not even be recovered in the end properly, unlike the monetary damages. But our solution will aim to prevent the damages preemptively and also learn from the gathered data that can be collected from the sensor technology and stored indefinitely. So the data collected from the sensor technology can be from temperature data, the humidity data, light, the gyroscopic data, and it can be viewed from an application as seen here. So, for example, with the cargo, we can see information from a certain cargo container, what information it has, and what is happening with the cargo container. For example, we can see the first cargo container, for example. It has temperature data, which tells what is going on. If the temperature is getting too high, there might be a chance that the cargo container will be damaged due to temperature changes. So the data here enables the worker and employees to rectify the damages before they even happen and before the losses even can occur. And of course, the data can be used for the clients and UPM Logistics themselves to learn about the situational context that happen with the sensor technologies and the cargo containers. Thank you.
No kuvatkaa ihmeessä.
Kuvatkaa. Sitä varten tehdään täällä olla.
Sen takia täällä ollaan. Lontooksi pitäisi vetää muutama minuutti ja demoa ja voidaan zoomata sitten aina lähemmästä tulee jotakin.
Yeah. So, are we ready? Yes. Basically, our main idea is to install sensors inside every container, and it provides you data from temperature, humidity, location, so on, everything that happens inside the container. And in every checkpoint where the container goes to another distributor, the containers will be read. There's a QR code installed outside of the container looking like this, and this QR code will be read by the automatic camera system, and every data from inside the container and what has happened there will be sent to our application and to our database where it can be analyzed and processed further. And our solution looks like this. Basically, you can check what's going on inside the area. If there's something happening, you can see the status of the harbor. Is everything going well over there? Then you can see more specific data from the containers, temperature, humidity, so on. And then you can check the status of the cameras. Are they working? Are they tracking? And then you can see every container that is scanned, and you can gain data from them. You can see immediately if there's something happening, and you can go to check them out. And yes, you can talk more about the...
Yeah, and this specific sensor is provided us from Logmor, which is a company here in Jyväskylä that produces sensors like this. And this sensor measures temperature and light that it detects. But Logmore is right now making a sensor that measures all these data that we need for our solution. So temperature, shocks, tilt, humidity, location, and ambient light.
And the reading of the QR code is this simple, so you just basically... Yes, can you give the QR code out?
Yeah.
So you read it like this, and then you can see immediately the data inside from there. For example, that the room temperature right now is 27 degrees, and it has been the highest point was like 29.5 degrees an hour ago in the room. So you can see immediately the real-time data from there. That's about it.
Yeah, thank you.
Joo, se passaa. Tää piti englanniksi vetää.
Lontooksi mieluummin, kyllä. Minuutti pari jäi.
Joo.
Ottaa yleiskuvaa eikä sitten voi zoomata, jos teillä on demoja, jota haluatte näyttää.
Joo, mä vähän osoittelen tohon sit.
Hetki saadaan.
So hello everyone. Here is our solution. It's called GoFog. Basically, our idea is to provide an infrastructure for the navigation of the vessels. So there's a problem in the seas that the navigation is hard, and the ships are hitting islands and stuff. So our solution offers remote navigation for that. So we utilize cloud computing and fog computing, which means that in the ships, every ship works as a fog node. So they together create a fog network. So in the sea, there's every ship, and they together create a fog network, which allows us to connect our remote piloting system to the fog network, and that way we can spread the internet whole network to the sea. And as you can see here, these are our layers, which means that here is the remote piloting, here is the sea, which means the whole fog network, and here's the cloud computing, which is ultimately the technology in which the whole system is running. And here is our remote piloting system. It's UI, user interface. We have in our demo this big black button is an indicator which shows which way you are steering the boat. So this is the user interface the pilot can see. So it means that he can sit on his couch in home and steer the boat to the harbor. The user interface has certain buttons which provide some information for the pilots. Here is the navigation panel which shows where the boat is going. And here you can see the sea traffic, all the other boats, and some weather information and cargo information, whatever the pilot needs to know. So this is our solution to the piloting problem of in the maritime. Thank you.
Minuutti pari englanniksi.
Voidaan mennä ihan vaan tällä näin. Yeah, so our solution wasn't some simple service for a one problem. We have an architecture for the base of all these solutions here. So we utilize 5G sensors and cloud-based services. So every piece of data that is collected from logistics, containers, weather, cranes, etc. is straightly is gone to the cloud via 5G network, which is fast, which is future. So, for example, in problem cases there is some damage happened. We can see when the damage is happened, by whom the damage is done, what kind of damage it is. So it is possible that when we see the damage has been occurred before we send the container, for example in South America, we see, okay, there's some damage, it's done by the truck, forklift driver, we don't send this, so we don't have to pay the cost to send it back to us. And we see, okay, this is the forklift driver who has done this. It is the responsibility of the harbor to pay this for us. It's not who will pay, it is the harbor itself. So, not a service, it's an architecture to solve multiple problems, not one. Thank you.
Tähänkö puhutaan? Okay, so this is our solution. It's called Smart Cargo, and you notice the nameplate. We use AR, so it's called Sea Air Go. So the idea is that the foreman who oversees loading the ship wears AR glasses, and the containers are attached with sensors. And the sensor data and the other data that's inputted from to the cargo can be seen by the foreman loading the cargo. But we know that it can be quite weather conditions when working outside, so that's why we not just rely on the glasses, but the foreman also holds a tablet, which you can manually then go and see the manual data. You can manually see the same data which you could see from the glasses. And the data includes where the cargo is going, where it's coming from, the weight, whatever. And the sensors also carry physical data like humidity and has the cargo has been tilted or whatever. So the idea is that the ship loading process in itself now it's very efficient as it is, but we could make small time savings with our solution, and in the long run we would save quite a lot of time, and that means money saving. Thank you.
Okay, so here is our solution. Here you can see the main idea about it. So when the containers come to the port, there will be a computer vision that gathers the data from it, and it utilizes that data to arrange. There will be an automatic system in the port that with the data catered, it organizes all the containers in a correct order for the loading operations. And there is some more material from it, so there will be some cameras that collect the data, and that data will be analyzed by computer vision. And there's some of the data that we thought might be useful, so some identification, weight is crucial for the loading, and maybe some 3D modeling as well for monitoring the condition. It might be useful. And there's some material that shows how the computer vision works, so it kind of sees different objects and different labels that are attached on those. And in this container field will be the kind of automated solution that organizes the containers. And that's pretty much it.
So, our service. We are Team Summit and we have sensors. We are exceptional group on the sensor part because we have AI system with the sensors. Our sensor system, it can estimate if there is any weather or other problems, and so we can foresee any future damages on the cargo. The cargo, we are trying to cut damages and make more profits for the company. What sets us apart from the other solutions is that we have learning AI technology with the machine learning ability that can foresee any problems that occur. Oikeastaan siinä se olikin. Kiitos paljon. Thank you, thank you.
Okay. So this is our solution. It's called tracking. It utilizes ST-mode stickers that are beacon technology. They utilize Bluetooth low energy. The battery life is approximately 4 years, so they are really environmental friendly, and they can be reused, and there is ID in a ST-mode sticker that UPM can decide what information they want to store to the ST-mode stickers. But for example, we chose to put there like order information, like when is the delivery going to be there, and when is the like estimated arrival, where is the order right now, and when is the last time to modify the order. Yeah, so here is like the user interface. This is what customers can see. So there is the start. They can see the orders there, the order information, where's the order, and here is the start. So they can make the orders in this application, and they can see and track the orders. And here is the order ID. So this is basically our solution, and you can use the application either on mobile application or desktop application. Oliko siinä tärkeintä? Joo. Oli. No niin.
Jos ei haittaa. Ottakaa sitten vaan niin. Okei.
Minuutti pari jälkeen.
Englanniksi, okei. Siis mä otan nyt, joo.
Mitähän se on?
Okay. So, voinko aloittaa? Yes. So, hello, we are Team Luotsi, and our solution is smart fairway navigation autonomous pilotage. And our point of our system is it's scalable, it's safe, it may be autonomous, but it doesn't require it.
because we already have so much data. Can you show the data? So we are producing lots of data that is required by the law, and we don't process it. So we are proposing a system to the ports that can analyze the data and use it for autonomous pilotage, and it doesn't require implementation on the ship side, but if they want to invest in technology, they can be piloted automatically to the ports, and it will like produce efficiency to the by eliminating the crews. And if you don't want to invest in the technology, the system can use technology which is required by the law, example radios. If let's say the sea weather is calm, we can provide some kind of like audio pilotage, so you don't require any technology to it. And we have demonstration video also, but we didn't have time to set it up for you because you were so fast. Did we have anything do you have any questions or? Okay. And here's our demonstration, how our solution will work. This is an example. Yeah.
Pitäisikö pitää tässä ja ottaa se? Tuleeko kuka puhumaan? Millä kielellä te haluatte? Englanniksi. Sulla on parempi englanti. Mitä mä selitän? Selitään, että miten se toimii. Siis toi demo vai? Niin, selitään, että sä saa ne tuontitiedot ja miten se toimii, miten se voi demo. Meni tässä ihan hirveästi aikaa enää pakko alkaa puhua. Minuutti pari esitystä.
Okay, so here we have... Mitä mun pitää tehdä? Pitää sitä? Näin iso. Yeah, so here we have our demonstration. As you can see, we have the container ID here. And we're going to look at some of the information, more information about this particular container. So you can see the sender and the receiver, the content, for example. And then we can see the route of this container. So this one's going from Rio to Panama to New York to Helsinki, for example. Then we have the information on where the container is at currently. So we can see from the picture here that it's by the coast of the United States. This is received through the ICE system. That's then communicated into the SHAS system. And then finally we have the port and where the container should be then placed. So the forklift driver will get the information on where to drive the container. So that's our system, SHAS in short. Yes. Thank you.
Hello. Okei, tuleeko teiltä kysymyksiä vai?
Se on pelkästään vitsi teille. Vastaan nopeasti. 2 minuutin myyntipuhe.
So we are Shipwreck Technologies, and our plan is to create autonomous container tracking system. So how does it work? So our plan is to put a text recognition camera to every harbor, and then the cameras will read the container number from every container, and then the number will go straight to the same database, and you can see where the ships and containers are at the moment at the real time. So that will help the customers to know where the ship is right now and where the container are. That will help also the harbors, the logistic problems, and yeah. Does Ilari want to say something about it? Yeah.
Okay, so the idea is pretty easy and cheap to implement, because we already have text recognition cameras that are working. The containers already have these ID numbers, so we don't need to have any individual sensors in them or anything like that. We can just read the code from here with text recognition camera, and then the information can be used for tracking.
Yeah, thank you guys.
Hello, our team is Lights Off, and our idea is presented here mainly. So the main concept is to develop a smart harbor and facilitating by drones. So as you can see, here are a couple of demos showing what the drone actually does. The first one shows that there's an potential oil leak, and the drone detects the oil leak and then traffics the oil pump there, which covers the accident. And the second one here, the drone could also be used by repairing the ships and using to receiving information and gathering data from the ships and the vessels. Yes, thank you.
We are Team Caribbean. I am Minna, and I will introduce you our solution, autonomous cargo handling. And we created automated harbor for those cargo and containers that are stored in the harbor area for a longer period. And this is efficient, environmentally friendly, and increases safety in the harbor area. And we concentrated on the autonomous truck lifts, which uses ConExpert scanning for the container and the containings.
So next up I'm gonna show a demonstration that we made. Here is the map of a harbor. Here you can see the depot unit, and the depot unit is used whenever a truck lift picks up a cargo, scans it, and it has a failure, or it's not good enough quality. The truck will drive to depot unit, in which the engineers can see what the problem was with the cargo. And here you can see that ship lift that will lift the cargo containers to the ship from the automatic truck lifts. Alright, so let me put this on. So you can see the two trucks, the cargo lifts, that they drive autonomously, and they pick up cargo packages and scan them. And if the cargo package was okay and it was good enough quality, it will be shipped. It will be the lift will drive it to the ship lift, which will lift it to the ship to be shipped further. And there you can see an error was found with that cargo, so it gets driven to the depot unit for further checking. Thank you.